Greetings, AP Chemistry students. This is Mr. Harper with your first episode of the summer podcast. Now, before we actually start, let me just tell you about kind of the purpose of these podcasts. I'm not going to cover everything that is in the first three chapters of the book here during the summer podcast. I'm going to leave that to you guys to read. What we're mostly going to focus on here through these podcasts are some of the more difficult kinds of calculations that you guys are going to face, so I can kind of clarify this for you, and also some of the really important concepts that are covered during those chapters of the book. In episode 1, what we're primarily going to talk about is some of the content in chapter 2, which is primarily, or at least we're going to talk about moles. A very important idea you're going to see throughout AP Chemistry, okay? Before we do that, even though, a few announcements, okay? Right now you guys are on summer vacation. I hope you're all having a good time. Something you might want to have on your calendar, just so you guys know it's approaching, is August the 17th. That is the first day of school, the 2011-2012 school year, okay? On the first day of school, we're going to have an introduction to the class. We're going to have a quiz on your ions. So all those things you're supposed to have memorized, okay, make sure you've got those memorized by then. I really recommend having doing flashcards because you'll need to know those ions all year, okay? I'm going to collect the summer homework from you, and including the lab, and we're going to have, of course, the quiz that day. Now, before the first day of school, on the 12th, that's the last Friday of summer vacation, okay, from 8 in the morning to about 1 p.m., I will be in my classroom, which is room 1111. I'm probably going to be 1111. There we go. I can count the number of ones. Okay. I'm going to be setting stuff up, but if you guys want to come in and ask me questions on that day, anything specific, any problems from the summer homework you want to go over, things like that, I'll be available during that time for you to do so. Otherwise, you guys can email me and I'll do my best to respond to your queries, but it is difficult to answer specific calculation type questions via email. So if you want to bring anything that day, I will be there. Please do not save everything, of course, for that last Friday because you won't be able to finish, okay? Once we start back to school, okay, so the 17th is the first day, the 18th is the second day. On the second day of school, we're going to do some review of important concepts out of the summer homework. And then on the 19th, okay, the third day of school, there's going to be a test on chapters 1 through 3, okay? So your first test is going to be the first week of school. There we go. So make sure you've done all you need to do to prepare for that. Alrighty. So chapter 1 is kind of basic information. We'll leave that to you guys to read. Chapter 2 presents a lot of different key ideas that are going to be on that first test that you guys need to be intimately familiar with. First of all, it talks about atomic structure, how atoms are put together. You want to go back and refresh yourself from last year. Know, of course, the nucleus of an atom contains protons and neutrons, and that is surrounded by electrons, okay? Nextly, it's going to talk about isotopes and atomic mass, okay? Isotopes, of course, we should remember from last year, are different forms of an element that differ only in the number of neutrons they contain. They, of course, would have the same number of protons. Because of different numbers of neutrons, they're going to have different atomic masses, okay? So know what isotopes are and know how your average atomic mass is calculated from isotope abundance, okay? Also, it talks about the periodic table quite a bit. You guys want to be familiar with the periodic table, how that is put together, and also this idea of periodicity, okay? What this term means, periodicity, is that the properties of the elements are basically repeating functions of their atomic number. For example, if you look at atomic radius, okay, you will remember from last year that as you go from left to right across a period, otherwise known as a row, on the periodic table of the elements, that the atomic radius will decrease. And then again, say we go across period 2. As you go across period 2 on the periodic table from lithium to neon, the radius of the elements decreases. They get smaller. Then if you go back over to sodium in the third period, okay, the radius again is big, and as you go across to the right across the third period towards argon, the elements get smaller and smaller and smaller and smaller and smaller, okay? That's periodicity. That's the idea that the properties of the elements are repeating properties of their atomic numbers. So you need to read up on that. What we're going to talk about today, and what is possibly one of the most central ideas to chemistry and the class AP chemistry you guys are going to take next year, is the concept of the mole. Okay, so that's what I want to talk with you guys about today, and you guys should take some notes as we go through and talk about it. This is, again, if you should probably be familiar with this already from last year. This is just kind of to jog your memory and keep you from forgetting everything that you already know, because if you're anything like me, I forget a lot of stuff over the summer, and it's kind of useful to brush up on it as we go. All right, so what is a mole? Okay, when we're talking about a mole in chemistry, a mole is not one of these furry rodents right there that burrows in the ground. A mole is a number that has special significance, okay? Now, this particular number is equal to 6.02 times 10 to the 23rd power of something. You should remember that number from last year. This number is sometimes called Avogadro's number, okay? And how it is defined, how we came up with this number, is that this is the number of carbon-12 atoms in exactly 12.00 grams of carbon-12, okay? Now, this thing, carbon-12, what is this carbon-12? Well, carbon-12 is a specific isotope of carbon. It is a carbon atom that has exactly 6 protons and exactly 6 neutrons in the nucleus, and its atomic mass would be, because of that, 12.00 AMU, okay? If I have 1 mole of carbon-12 atoms, that 1 mole of carbon-12 atoms has a mass of exactly 12.00 grams, okay? And it turns out that in that 12.00 grams of carbon-12, there are 6.02 times 10 to the 23rd power atoms of carbon-12, okay? Now, what's the significance then of this, okay? Now, why this idea is very important, why the mole is very important, and why we're going to keep using moles all through chemistry is because the idea of the mole relates mass, an observable thing, okay, to a number of particles, okay? This is something you should probably write down, in fact, okay? The significance of the mole is that it relates masses, which are measurable in the lab, to a number of particles, okay? Relates the observable quantity mass to the unobservable number of particles, because we can't very easily look at a sample and say, well, we have X many atoms of carbon or copper or oxygen or what have you in that sample, but we can measure a mass. And using the idea of the mole, we can change that, or we can relate that rather to the number of particles, or which are either, when I say particles, guys, this is kind of a generic term. This could be atoms, okay? This could be molecules. If we're talking about ionic compounds, this could be formula units, okay? Or whatever, okay? So when I say particles, understand that what I'm saying is the little tiny bit of matter that makes up the substance we're talking about, okay? So there you go. That's why it's important, okay? Now keep in mind, again, this number, 6.02 times 10 to the 23rd power, or 1 mole of something, is just a number. I can have a mole of anything. In chemistry, sometimes I deal with a mole of atoms, a mole of molecules, a mole of, something. I could have a mole of students, okay? It doesn't matter. I can have a mole of anything. All right. Okay? Now, going along with this idea of the mole, okay, is another term, which is something you guys need to understand, which is called molar mass, okay? This is defined as being the mass of 1 mole of a substance, okay? Now, keep in mind that when I say 1 mole of a substance, what I'm really talking about is 6.02 times 10 to the 23rd particles of that substance, whatever the smallest particle of that substance happens to be, okay? For example, if we look at the element sodium, okay? If I'm talking about the element sodium, the smallest particle of sodium is an atom, okay? This is an important thing to realize. The smallest piece that I can have of sodium is 1 atom of sodium, okay? Now, if I look at the periodic table, I'm going to find a symbol for the element sodium, okay, which looks like this. It has a symbol Na. Okay, and this symbol here has 2 numbers. We look up here at the top. Okay, this is the atomic number of sodium. And if I were to ask you guys on the test you guys are going to have on the first Friday of the year, what does the atomic number of an element represent? Well, of course, you could tell me that this number right here represents the number of protons in the nucleus of that atom. Down here, we see another number, 22.99. What this is right here, this is the average atomic mass, okay, of that particular element. And this is measured in something called AMU. AMU stands for atomic mass units, okay? Now, what's special about this number is that if I'm talking about 1 mole of this substance, okay, 1 mole of sodium has a mass of 22.99 grams, okay? And this holds true for any element on the periodic table. The atomic mass down here, if we're talking about 1 mole of that substance, is going to be in grams, okay? So 1 mole of sodium has a mass of 22.99 grams. Another way of saying this, and this is the way it's most commonly reported, if I ask you for the molar mass of sodium or something else, you're going to tell me, well, the molar mass of sodium is 22.99 grams per mole, okay? Grams over moles. It's a ratio of how many grams are in 1 mole. Or I could say it like this. I could just write it like 22.99 grams over moles, okay? This either way is the same thing right here, okay? So that's an element, sodium, okay? Now what about something else? Like water, for example. Water is a compound. We have more than one element here. We can see that in every piece of water, every particle of water, there are 2 hydrogen atoms and 1 oxygen. That's what this formula here tells me, okay? So the smallest particle here of water is a molecule. Okay? Now, if I have 1 mole of water molecules, that's going to have a certain mass. Well, just to review, guys, here's how we find that, okay? This is made up of 1 oxygen and 2 hydrogen atoms, okay? If we look at our periodic tables that I gave you guys before we left for summer vacation, if we look here at oxygen, you're going to find that the molar mass of oxygen is 16.00 grams per mole, okay? If we look at each hydrogen, okay, that has, according to your periodic table, a molar mass of 1.0079 grams per mole. Just for the sake of ease, I'm going to abbreviate this. We're going to round it to 1.01 grams per mole, okay? Now, since I've got 2 of these, I'm going to multiply this by 2, okay? And if I want to know what the molar mass of this compound water is, I'm just going to now add this all together. And if I do that, I'm going to get 18.02 grams per mole, okay? So when you're finding molar masses for a compound, you just add up the masses of the constituent elements. And there you go, okay? You did this a ton last year, but then again, this is just for the sake of review. Okay. Let's look at some calculations involving moles, okay? Just to kind of get you back in the habit of doing that sort of thing. These are some that are off of your homework. Let's look at problem 41A, okay? It says, calculate the number of grams in 2.5 moles of boron, okay? Now, this is really kind of a simple example, but there's more than one reason why we're going through this, okay? Number one, of course, is that this has to be, when you walk in the door next year, reflexive. You have to understand how to do this kind of intuitively. But the other one is that I can demonstrate to you how I want you to show your work in my class, okay? As you know, one of the main goals of advanced placement chemistry is preparing you for the AP test. On the AP test, you need to show very clear work, including units. Hence, on my tests and in my class, you need to show complete work with units. And wherever possible, we're going to do that work by dimensional analysis or unit analysis, as Mrs. Mafucci might have called it last year. I don't know exactly what she calls it, but dimensional analysis is the term that I'm going to use. And usually when we do a calculation, guys, what we're going to start with is going to be the given information, okay? What we're trying to find here is the number of grams. That's what we're trying to find. The given is 2.5 moles of boron. So I'm going to start by writing that down. I have 2.5 moles of boron. Now notice what I'm doing. I'm giving a number, but I also have a unit, and it's specific, not just 2.5 moles, but 2.5 moles of the element boron, whose symbol is a capital B, as I need to be specific. Now, if you didn't write these units down on a test, you would be wrong, because a naked number has no meaning in chemistry. units are a given number meaning, okay? It has to specify what it's talking about. Otherwise, if you didn't have this on here, you could be talking about 2.5 elephants or 2.5 cars or something, or in my particular hobby, which is reptiles, okay, the number before the decimal specifies number of males, this specifies number of females, so this could say 2 male snakes and 5 female snakes. You never know, okay? So you must label with units all the time. Okay, the next thing we're going to do to convert this to grams is I'm going to multiply, as you guys may remember, by a conversion factor. When we do dimensional analysis, this is going to be a ratio, a fraction, okay, where the unit we are trying to get goes up here on the top, and the unit that we're trying to get away from goes on the bottom, okay? Now, I'm trying to convert away from moles of boron, so moles of boron is going to go down here, okay? I'm going to put grams on the top. Now, in 1 mole of boron, how many grams are there? Well, we're going to get that from the periodic table of the elements. If I look here at my periodic table, I can see that there are 10.811 grams in every 1 mole of boron. The units here cancel out, and now if I do the multiplication, I'm going to get my number of grams. Okay, here we go, guys. Whip out the calculator. 2.5 moles times 10.811 grams is going to be 27.0275 grams. And there we go. Now, in reality, we wouldn't carry this many decimal places. We'll save that conversation for another day when I teach you guys about significant figures. For now, we can just box that answer and call that baby good. Okay, there we go. That many grams. Now here we go. Number 43, let's do another one. Okay? Here we're going to do something a little bit different. Calculate the number of moles represented by 127.08 grams of copper. Okay? Now here we're going to do the reverse process. We're going to change a mass into moles. Moles what we want to find. Here's our given. So I'm going to write that turkey down. 127.08 grams of copper is my given. I want to find the number of moles. So I'm going to multiply by a conversion factor. Moles is going to be here on the top. Okay, and then grams is going to be here on the bottom. We're going to make a ratio out of this. If I look at my periodic table, 1 mole of copper has a mass of 63.55 grams, okay? Grams here is going to cancel out. Now to find the number of moles, take 127.08 times 1 divided by 63.55. If I do that on my calculator, let's do that. 127.08 divided by 63.55. And here we go. We're going to get 1.999685, which is about the same thing as saying 2.00 moles of copper. And there we go. That would be the answer to that problem. Okay. Hopefully that was clear. You guys have done this a whole ton of times this last year, but this is just for the sake of review. All right, next. Let's do another one. Problem number 49 says, if you have a 35.67 gram piece of chromium metal, chromium metal has the element symbol of Cr, by the way, on your car, how many atoms of chromium are in the piece? Okay? Now, we can't convert directly from grams to number of atoms, okay? What we can, however, convert grams into is moles. And then we can change moles into the number of atoms, okay? That's going to be the mathematical approach for this problem. And that's the importance of the mole concept. It provides a bridge between grams, or mass, and a number of particles. I think I've said that a couple times. All right. So like you guys should be wise to by now, when we show the work, we're going to start with the given. The given is this right here. We have 35.67 grams of chromium metal. My first step is going to be, I want to change this grams of chromium into moles of chromium. So here we go. 1 mole of chromium has a mass, according to the periodic table, of 52.00 grams, okay? Now, when I do this, I'm going to cancel out my grams, and now my new unit is going to be moles of chromium. Now, I could go through and simplify my answer here and then do a separate mathematical process, but I prefer to show all the work all in one strand, okay? So now we're going to do the next thing, okay? I have moles of chromium. That's my existing unit. I want to change that into atoms, okay? So I'm going to again set up a different conversion factor, okay? I'm going to get rid of my moles here. Now, 1 mole of chromium has how many atoms? You guys should know this. 1 mole always has 6.02 times 10 to the 23rd power atoms or particles or molecules or whatever, okay, of your thingy in there, okay? So moles of chromium is going to cancel out. We're going to have left units of atoms. Okay, let's go through here really quickly and simplify these numbers. Okay, 35.67 divided by 52 is going to be something times the quantity, 6.02 times 10 to the 23rd power on my calculator, and the number that I get is 4.13 times 10 to the 23rd power atoms of chromium. Now, here's a pro tip here for you. When you guys are doing calculator work with this number right here, what I really would suggest that you do is put this number in parentheses. That way you avoid making any sort of order of operations error with this number. And also, when you put this into your calculator, the way to do this usually is there's on most calculators, at least Texas Instruments calculators, a button that looks like this, EE, okay? This is the same thing as saying times 10 to a power, okay? So if I put this in my calculator, it's going to look like this, 6.02 EE23, okay? There we go. That's how I put that in my calculator, and there's my answer. So that's all I had to show you guys today. If you have questions on anything we did, get friendly with your pause and rewind and whatever on your computer and go back and watch it again. I hope you guys are having a great summer. Until the next podcast, I wish you good day. Hasta la vista.